Today we're going to solve equations involving exponents. So notice that x to the a raised to the 1 over a is equal to x to the a over a. The reason being is our little multiplication rule, x to the r raised to the s equals x to the r times s. And then x to the a over a is equal to x to the first, which is equal to x. Maybe we can use that somewhere down the road when we're solving equations. X to the 1 over a raised to the a is also x to the a over a, because 1 over a times a over 1 is a over a, and that's also x to the first, which equals x. So when x or any variable is the base, raise both sides to the reciprocal of the exponent. So, for example, if you were asked to solve quantity 2x minus 98 to the 100th equals 0, would you want to multiply that out times itself 100 times? I know I would not. So we can take 2x minus 98 to the 100th, and we can raise both sides to the 1 over 100. So that we end up with just 2x minus 98 to the first equals 0 to the 1 over 100, which would just be 0. And we'd end up getting 2x equals 98 and x equals 49, a much more efficient way to solve it than to have to actually do 100 foils. So we can also apply that when we're solving equations with fractional exponents. So on our first example, x to the 3/4 can be raised to the 4/3. On both sides. And when we do that, we get x to the first equals, now remember, to do this, 27 to the 4/3, it is the cubed root of 27. The easiest way would be to raise the whole thing to the 4th. You could do the cubed root of 27 to the 4th. However, I wouldn't want to take the cubed root of 27 to the 4th. I think that's too hard. So I'm going to put it on the outside, because I know the cubed root of 27 is 3, and then 3 to the 4th is 81. And if I check 81, I want to always check in the original problem. So I would have 81 to the 3/4 equals 27. So that'd be the 4th root of 81 to the 3rd, which the 4th root of 81 is 3, and 3 to the 3rd is 27. The next one, you need to, with an example like this, you need to make sure you get the variable and the exponent alone. So let's add 2 to both sides, and then divide by 3. Okay, now, I know we've dealt with negative exponents. You could make it 1 over a to the 3rd, but it's also possible to just raise both sides to the negative 1/3. So we'd get a to the first, because a negative times a negative is a positive. And then we need to calculate the 27 to the negative 1/3, which is just 1 over 27 to the 3rd, which is 1 over the cubed root of 27, which is just 1 over 3. So going back and checking this, it would be 3 times 1/3 to the negative 3 minus 2 equals 79. Remember, to make that exponent positive, flip the fraction. That's another rule. And then you want to make sure you do exponents first. So 3 times 27 first, not 3 times 3 is 9. And then 3 times 27 is 81, and that minus 2 is 79. All right, next one. To the nearest hundredth, we're solving this one. So we have subtract 1 again. So we've got, now it's probably easier here to write this radical as a fractional exponent. So I'm going to do 3x to the 7 over 2 equals 24. Okay, remember the root goes on the bottom, and then divide by 3. So I'm solving x to the 7 over 2 equals 8. So x to the 7 over 2 equals 8 can be raised on both sides to the 2 over 7. And so that gives me x to the first. And then 8 to the 2/7, I can't figure out the 7th root of 8 squared without help from my calculator. That is not a perfect 7th root. So I'm going to go to my calculator and type in 8 to the 2 divided by 7. So 8 to the parentheses 2 divided by 7. And so I want to take that decimal and round it to the nearest hundredth. So I did 8 caret 2 divided by 7. And I get x is 1.811447 dot dot dot. That's approximately 1.81 to the nearest hundredth. All right, next one. Take and add 3 to both sides. So we get x to the 2/5 equals 9. And then raise both sides to the 5 over 2. So we get x equals the square root of 9 to the 5th. So x equals 3 to the 5th, and 3 to the 5th is 243. Number 10, I'm going to first start by dividing by 9. So I get a to the negative 3/4 equals 1/3 divided by 9, which is the same as 1/3 times the reciprocal. So 1/3 times 1/9. So a to the negative 3/4 equals 1 over 27. And then I'm going to raise both sides to the negative 4/3. So I get a is equal to, and I'm going to flip that to be 27 over 1 to the positive 4/3. And then I'm going to go with the cubed root of 27 to the 4th. So a is equal to 3 to the 4th, and a is equal to 81. Next, subtract 14 and divide by negative 4. So b to the 1/3 equals 3. And then raise both sides to the 3 over 1, or to the 3rd. And so you get b to the 1st equals 27. And then for 16, you could take the 5th root of both sides, or you can just raise both sides to the 1/5. And then when you calculate that, you are going to have to take the 5th root of 3,125. You can do it either way on the calculator. Let's take a look at that. So I'm going to do 3,125 to the 1 divided by 5. which is 5, or I'm going to take the fifth root of that. So I'm going to go 5, math, choice 5, and 3,125 inside there, and I get 5. So either way, you get 5. And then, of course, you can go in and check those. And that's it. Have a great night.